Hi friends, welcome back. Now let's get into the second solution for deadlocks, that is the deadlock avoidance. Here we grant the resources to any process if doing so keeps the system in the safe state. That means before granting any resource to any process, we just verify whether the system will remain in safe state or not. If we guarantee that there is no harm to the system, it's going to be safe, only then the resources are granted to the requesting process. So now question is, what do you mean by safe state? So a state is safe if there exists at least one sequence of all the processes such that each process can finish even if all request their maximum resources right now. What is it trying to say? That we have a set of processes, we have a set of resources, and some of the resources are already locked by the processes, and the processes are demanding for more resources. So the question is, can we continue providing these resources to the requesting processes or not? For doing that, we just look at, if we do so, is there any way that all the processes can complete their task? Is there any sequence in which if we run the processes, then all the processes will complete their task, and hence there won't be any chance of deadlock? So that state we call a safe state. So from a state, we should have at least one sequence of the processes execution such that each process can finish even if all request their maximum resources right now. So that is what safe state is. Unsafe not necessarily mean deadlock, but definitely an unsafe state can lead to deadlock if not corrected in right time. So we want to ensure every time that our system is in the safe state. That means any situation from there, if we find at least one path to a state such that all the processes currently on complete their task and terminate themselves. So that is what we call a safe state. And if we don't find such a path, it doesn't mean that there will be deadlock. So, but yes, chances are more that it can lead to deadlock if proper care is not taken. How does this work? So how do we avoid the deadlocks? So each process must declare its maximum resource requirement in advance. That's the first thing, that whenever a process comes up, it must declare itself that I do require these resources, and how much of each resource is required. That is to be declared well in advance. Then the operating system keeps track of how many resources are available, how many are currently already allocated to various processes, and what each process still needs. Whenever a process requests a resource, the operating system simulates allocating resource. So it doesn't allocate, but it starts simulating that the request, if granted, what could happen in future. If granted, what could happen in future? So assume that it is granted, and after granting that request, will we be able to complete all the tasks in some order or not? At least one sequence of process executions is required from that point onwards, so that every process gets executed. So just simulate this. So before allocating, whenever we get a allocation request for any resource, the operating system starts thinking, should I not? So it starts imagining, if I give permission to use this resource, then what would happen? Will we end up in a deadlock, or will it be safe? If at all the simulation result says that it is safe, only then the resource will be allocated. So it runs some safety algorithm to check if the system remains in a safe state, if that resource is allocated to the requesting process. So we just at every point before allocating a resource, we stop, look into the future, what could happen in the future if we take this step. If it says everything is okay, nothing to worry, then let us allow allocating this resource. If it is saying that no chance of finishing all the processes, then we understand that it is not a safe state, so we will not allow our system to enter an unsafe state. So to make sure that it is going to be a safe state or unsafe state, we just visualize, we just simulate and try to see where it leads to. Will it lead to safe state, or will it lead to unsafe state? We just visualize without allocating. If we allocate, what happens? Goes to safe state or unsafe state? If we find that it goes to safe state, only then let us allocate the resource to the requested process. If we are not sure that it is going into the safe state, then let us avoid allocating that resource to the process. So that's how we have to ensure, visualize before allocating anything, and that's how we say that it can be avoided. A situation getting into deadlock can be avoided. So that's the second way of working, it is deadlock avoidance. But yes, we require some way to visualize in the future, will it lead to a safe state or not, and that is done by many algorithms, and one of the most popular algorithm is called Banker's algorithm, and that algorithm is going to identify a sequence of processes that can be run so that we can complete all the tasks. So will it provide any sequence so that we can complete all the tasks? Then we say it is safe. If it is not possible to find any path, then we say unsafe. So that is what Banker's algorithm is going to help us. So in the next session, let us see what Banker's algorithm is all about and try to understand what it is, how it works. Let's take some examples and then try to understand what the Banker's algorithm is and how it helps us in visualizing into the future to know whether the state is going to remain safe or unsafe. So that's it for now. Thank you.